Okay, class, we are now going to start the notes.
Is it recording?
It is.
Oh no.
Hey, so if you turn to the sideboard where I'm at, please, thank you. On Tuesday, Trooper Tide Tuesday, the 4th of this month of December, which today is, all day long, in geometry, the middle row, SWBA students will be able to use CPCTC, we'll talk about what that means, to find side and angle measures and determine triangle congruent, which is section 4.4. Let's get started.
I didn't know. I really don't. Oh, these are the hard ones. Those are not it.
Okay, but you turn in them. You have them.
Wait, I really do it.
Is that back?
That is so long.
Yeah, which is why we abbreviate it as CPCTC. That way we don't have to say it. Hey, so Joe, tell me again what CPCTC stands for.
Corresponding parts of congruent triangles are congruent.
Very good. So we're going to be talking about this and what it means, okay? So first, talk about congruent figures. So congruent figures, you've had the congruent sides, you've had congruent measures of angles, you have congruent segments. Now we can have congruent figures. So like triangles can be congruent. So congruent figures have the same size and shape. Congruent figures have the same size and shape. What?
That made it.
You just pointed. Hey. What? Oh, gotcha. Okay. Corresponding sides and corresponding angles are congruent as well in congruent figures. So you'll know these two things about congruent figures. They have the same size and shape. So if one's a triangle, the other one's going to be a triangle. You're not going to have like a triangle and a square. And they have to be the same size. So corresponding sides and corresponding angles are congruent. Okay, so we go down here. We have congruent statements, and then we can have corresponding angles and sides. First, talk about the corresponding angles and sides. So corresponding angles, what's correspond mean? They relate. Okay, they're connected in some way. So last chapter we had corresponding angles, and those were angles that were kind of in the same position as the vertex, remember? Okay, so if one was in the top left of the vertex, of one vertex, the other one was also in the top left of its vertex. So here, if we have angle A, that's in the bottom left of this triangle, but more specifically, it's the one with one arc. Which angle in this triangle would correspond with angle A? Angle F, because it also has one arc. Okay? More importantly than where it's located, we want to look for that arc to make sure we know it's congruent. Or sometimes we will look for which sides it's between. This angle is between the side with one tick mark and two tick marks. Angle F is also between the sides with one tick mark and two tick marks. So they correspond. And somebody else give me another pair of corresponding angles. Okay? Levi.
D.
Angle D and angle
C.
C. Very good. Angle D and angle C would also correspond. Okay? D has three tick marks here, and C has three tick marks here. D is between the one with the side with three tick marks and the side with two tick marks. C is also between the side with three and two tick marks. Somebody else want to give me the last pair of corresponding angles? Ryan.
B.
Angle B and angle
E.
Very good. Angle B and angle E would also be corresponding angles, okay? So there's the third angle in each triangle, the one we haven't used. And angle B has two tick marks, or two arcs. Angle E has two arcs. Angle B is between the side with one arc and the side with one tick mark, and the side with three tick marks. Angle E is also between the side with one tick marks and three tick marks. So we also have corresponding sides. Same story here with corresponding sides and with corresponding angles. So give me an example of corresponding sides. Caitlin. Very good. AB and FE. So segment FE or AB and segment AB and segment FE. at these. Look at these. Segment AB, side AB has one tick mark. Side FE has one tick mark, so they're congruent to each other. They're between the angles with one tick mark, or one arc and two arcs. FE is between the angle with one arc and two arcs, so they correspond. Somebody else give me another pair of corresponding sides. Free. Very good. Side BC and side ED. I agree. Side BC, 3 tick marks. Side ED, 3 tick marks. Side BC is between the angle with 2 arcs and the angle with 3 arcs. Side ED, same story, between the angle with 2 arcs and 3 arcs. Okay. And Julia, what's the last one?
The side AC and side FD.
Very good. Side AC and side FD. Okay. And could we also call that one DF?
Yeah.
Sure. Okay. So side AC and FD both have 2 tick marks. And they're both between the angles with 1 arc and 3 arcs, so they're corresponding. Yes.
If you call it side DF, would you also have to call it CA?
Good question. Eric asked, hey, Mr. Costle, if we call this one DF instead of FD, do we also have to call this one CA? No, we don't. Because either way, these are still the same side. CA and AC mean the same side, and DF and FD mean the same side. So that was a good question. We don't have to call it that. Okay, and like we said up here, corresponding sides and corresponding angles are congruent, and it's marked on the picture that way. It's how we identify them, actually. So we can also have a congruent statement. And if you look at the congruent statement, this is an example. Triangle ABC is congruent to triangle FED. If you look through this, if we look in the order, the first letter here is A. Angle A corresponded with which angle? F. So the first letter in this triangle is F. The first letter of each correspond. The second letter B, what did angle B correspond with? Angle E. What's the second letter of the second triangle? E. So the second letters correspond too. The third letter C, angle C corresponded with what angle?
D.
D. Angle D is the third letter. Do you guys think that's a coincidence? No. The first letters correspond, the second letters correspond, and the third letters correspond. So if I were to put this first triangle, remember we can name a triangle ABC, or I could call it BCA. That'd be congruent to triangle what? Who can tell me what triangle that would be congruent to? I would have to write that second triangle based on how we wrote the first one. Free. E, D, F. Very good. If we put the second letter first, B, and the first one, let's put the second letter first, E, and the second one. Same thing. If the third letter is not the second letter, third letter is not the second letter.
Oh,
First letter is the third letter, first letter is the third letter. So we have to make sure they correspond. And you can say, okay, B does correspond with E, C corresponds with D, and A corresponds with F. To match them up. Okay? So if I call this one triangle, let's go CBA. Could be certified business accountant or collective bargaining agreement. In this case, we're talking about a triangle. So triangle CBA is congruent to which triangle?
D,
Okay, Bree, why do you say DEF and why are you guys saying DFE? Okay. Okay, so you're saying DEF too. Okay. Okay, so if you kind of look at the triangles, because they're facing the same direction, they won't always be facing the same direction, but because these are, this one kind of starts C, it goes counterclockwise. This one starts D, goes counterclockwise. We can also look at the points, say CBA. It goes 3, 2, 1 based off the original, so the second one has to go 3, 2, 1. DEF. Or we can look here at our corresponding angles. Questions on that? So here we have congruent statements for these triangles. We have a congruent statement for the triangles itself. They have congruent statements for the corresponding angles and corresponding sides. What I want you to do is on all of these where I wrote the bracket, this kind of top half here, it's on your left half of your paper. Okay, so left half of the paper, middle section, right next to that 3-hole punch. I want you to fill in these 7 blanks. We have 7 blanks here, 3 lines, 7 blanks. I want you to fill them in. Okay? So, just like we kind of did before, where we say, here's the corresponding angle, here's the other corresponding angle. Here's this triangle, here's how we write the second triangle. So go ahead and go through that, please.
Oh my god. You did that wrong, but I'm okay. I did?
What was that? Okay, can I get a volunteer to go up and fill in that first blank? Okay. Julia, I'll go ahead and have you do it. And be ready, I'm going to ask for a volunteer for the corresponding angles. Yep.
Okay.
And I'll-
Corresponding angles.
Okay. Okay, so if we have triangle ABC, we would have to go triangle FGH. Because F corresponds with A, G corresponds with B, and H corresponds with C. Question on that first one. Okay, and it does have to be in that exact order. Paige, go ahead and do the angles, please.
Okay. Okay. Do I change the color again?
Yeah.
Yeah.
Except for that color.
Oh, well. Do we have to put the angles on?
Yep.
Okay,
What are we betting?
I told that to you yesterday.
Okay. Very good. It would be angle A is congruent to angle F, angle B is congruent to angle G, and angle C is congruent to angle H because those are the corresponding angles. Thank you, Bree. Oh, wholesome. Very good. Those would all be correct. Any questions on that one? Okay. I want you guys to go ahead and do these bottom 6. They're on your right. So for you, they're the right 6. For me, they're the bottom 6. Okay. And you can do it without even drawing the shapes. So go ahead and do those if you have not already, please.
Oh, I think I know what we're doing.
Cool.
Are those right in the right order though? The YRT and BC?
Yep, they have to be.
Then I know what I'm doing.
All right. You're right. Stop it. I'm so tired. I'm Mr. Castle. Oh, that's pretty decent. see that late. Okay, let's go ahead and bring it up here. Okay, so what's congruent to angle M? Angle Y. Angle Y. Why is it angle Y?
Because you said so.
First letter, first letter. You can tell because it's the way it is. Very neat. Kind of like an aspen tree. Okay. Angle C is congruent to angle T. Third letter, third letter. Segment BC is congruent to segment RT. Could we also call it TR? Yes, we could. Same segment. Segment CM is congruent to segment TY. Could we also call it YT?
No.
But you could, yes, you
The
can.
next one's Y.
This one, next one, MC. It could be YT or it could be TY. It'd be the same either way.
What?
Okay. Angle B is congruent to what angle? R. Second letter, second letter. Questions over that, class? Okay. Okay. So let's look at this. Let's look at this bottom-up example. Okay. We need to determine if this is enough information to figure out are these triangles congruent. So on the top left, bottom-up example for you. Determine whether the given triangles are congruent. Explain. Okay. So let's start going through this. We have a 60-degree angle here. We have a 60-degree angle over here.
Yeah.
Okay, so they're congruent. We can mark them congruent. Put one arc here. How many arcs will we put here? Okay. We have a 30-degree angle here. Do we have a 30-degree angle in this triangle?
Yeah, put 2.
Very good. We'll put two arcs. So they're not congruent to the 60-degree angles, but they're congruent to each other.
Then you put a big thick line of the angle, that one.
Okay. And we just need to highlight that these are right angles. Okay, they're already listed. If they're right angles, are they congruent?
Yeah.
Yeah, because they're both right angles. They're both 90. So we don't need to mark that. We don't need to put 3 arcs there. The right angles is sufficient for us to know, hey, they're congruent. Okay? So we don't know the angles are congruent, but we said they have congruent corresponding angles and congruent corresponding sides. So do these have congruent sides? Okay, well, let's go through this. This one has one with 1 meter. Does this one have one with 1 meter? Yeah, okay. Let's check. Do they correspond? Which two angles is this between? 60-degree and 90. Which two angles is this one between? 60 and 90. So are they kind of in the same spot?
Yeah.
Yeah, but this one's on the bottom of the triangle, and this one's at the top. Are they still in the same spot? Yeah, because this triangle, it could just be that this triangle was kind of like spun. It could be like kind of like you clicked on it and rotated it, right? Okay. Let's keep going. So we look at this one. This one has a hypotenuse of 2 meters. Does this one also have a hypotenuse of 2 meters? Yeah. Okay, and they're between the 60 and 30 degree, right? Is this one between 60 and 30? So they're corresponding. Let's do 2 tick marks to make sure they're separate. And our last side, 1.7 meters. Does that match up with 1.7 meters? Okay. And it's between 30 and 90. 30 and 90. So they correspond as well. Okay. So are all of our sides and all of our angles congruent? Yeah. So we can write a congruent statement. So triangle what is congruent to triangle what? Who can help me and write a congruent statement? Okay. So you can pick whatever first order you want, but your second order has to match. But
Triangle
I agree, okay? So if we do triangle GHH, GJH, GJH, we go from 30 to 60 to 90. If we do triangle KML, we went from 30 to 60 to 90, or 30 to 60 to 90. So we went the same order, which is good. Corresponding angles in that order. And we'll say, is says explain, so we'll say because all corresponding parts that's one word, are congruent. Yeah, they are, because all corresponding parts are congruent.
Yeah.
Yep.
Answer yes.
You answer yes, and this tells you yes. Because you wouldn't say they're congruent if they're not congruent. So this is your answer. Okay. You could also say, in order to be shorter, I'll give you the short part real quick after I told you. You can say GGH, here's triangle KAML by congruent parts of corresponding triangles are congruent. Corresponding parts of congruent triangles are congruent. You can also say that. This could be your answer instead. A little bit shorter.
With this test, are we gonna have like fill the blanks where we put like different kind of triangles, like isosceles?
Maybe.
Can you just tell me?
Maybe. Okay. Question on this first one. Okay, let's go to the second one. Sure.
We're done with further page.
Okay, so go ahead and do this on our own.
I just wanted to do it.
You can. So if it's right, we know it's right. If it's wrong, what do we write? Okay, if it's wrong, what you would write is you would point out the information that shows us that it's wrong. Point out where the flaw is. Point out why it's not. So if something doesn't match up, you could circle it. You could highlight those. You could write about it.
Okay, well, no.
That was me trying it up. Yeah, that'd be awesome. Yep. You have to write the word. At least one word.
No.
You can just write your verdict though. Okay, Tanner, what are you thinking? Are these triangles congruent? Why not?
Because line CB, line EF,
Okay, but these two have different measures. So why is this a big deal? Because they match up. What's our big fancy word for matching up? Corresponding. These corresponding sides are not congruent. That could be your explanation right there. No, circle, circle. This is the information that tells us no. Because 12.1 is screwed to 12.1, 7.9 is screwed to 7.9, but this one's not congruent, so they're not congruent triangles. Because all the sides have to be congruent. These aren't. Questions? Okay. Kaylin, what did you have as your explanation? What did you have as your explanation? Okay. Would this be an okay explanation? Segment CB is not congruent to segment EF? Yeah. So, explanation could be. What do you have?
So I had angle ABC is not congruent with angle triangle DEF.
Okay.
Because the line segment CB
That's still more complicated.
EF are not the same number.
Yes, that would work as well. It's longer, but that would work as well, right? Okay. So Paige said, hey, she has this triangle is not congruent to this triangle because these two segments are not the same number. So they're not congruent. Questions? Comments? Concerns? Next page, please. And thank you. So if we have congruent triangles, if we're given, top left, that these two triangles are congruent, triangle ABC and triangle DEF, we need to find the measure of x and the measure of y, or the value of x and the value of y, rather. The measure of value Okay? How can we go about finding these values? Well, what do we know about congruent triangles? Okay, what's the same measure on them? What's the same measure in congruent triangles? Are the angles the same measure? I'm asking. Are the angles the same measure in a triangle? Okay, yes. What kind of angles? All angles? So like this angle, C, and this angle, E, are going to be equal? No. Why not? They don't correspond. So what kind of angles are congruent? Okay, C and F because they are corresponding. So corresponding angles are congruent, okay? What about sides? Are all sides congruent? No. What kind of sides are congruent? Corresponding sides, okay? AB is where x plus 12 is. What's AB correspond with? AB's first two letters, DE. So that means AB and DE are congruent. So if AB and DE are congruent, what alarms and cowbells should be going off in our head? This side should be 21 as well. So what do we do if these two are congruent? Okay, how do you get that? Okay, so your original equation might be x plus 12. Congruent tells us to set them equal. So if we see congruent, if we hear congruent, we should think set them equal to each other. Alarms should be going off in our heads. You have a lot of drawings on your knees. Okay? So we should say, hey, these are congruent. Let's set them equal to each other. X plus 12 is equal to 21. Jordan, solve this one. Plus 12? What's 12 plus 12? 24. Did that help us? It did? Okay. Well, are we trying to get x by itself? Okay. So did that get it by itself? Alright, we're supposed to subtract. Let's subtract.
Oh, I got it.
While we're here, what's funnier than 24?
25.
25.
Shut up, Paige.
Okay. So we'll subtract 12. Jordan, what's 12 minus 12? 0. That's much better. Jordan, what's 21 minus 12? What would 22 minus 12 be? Good 22 minus 12. 10, okay. And 21 is 1 less than 22, so what's 1 less than 10? 9. So x would be 9. Oh, sorry, I didn't hear you. Oh, my bad. Yeah, it is. All right, Jordan, calm down. So, we need to find y. How can we find y? Eric. Okay, C and F are congruent. They correspond. So how does it help us?
It lets you know that 2y minus 8 equals 50.
Very good. That means congruent means they're equal. So if they're congruent, we set them equal. So 2y minus 8 is equal to 50. Now we need to solve this equation, okay? Quentin, help me solve this. Add 8 to both sides, get rid of it, is negative. Divide by 2 to get rid of the multiplication. And y is equal to what did you say? Okay, you want to phone a friend? 29.
What's
9? So the values of x and y would be x is 9, y is 29. Question on that one? Okay. The third angle theorem. Third angle theorem, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. They have to be. So we're saying if these two angles are congruent, A is congruent to D and B is congruent to E, two of these angles are congruent to two of another ones, then the third angles have to be congruent. Let's look at this. Okay? We're going to look at this and diagnose it. Someone give me a random measure for angle A. 65, okay? So if angle A is 65 degrees, what other angle is 65 degrees? D. Somebody give me a measure for angle B. 64, okay. So what other angle is 64? E. Okay? So how can we find out measure angle C?
You add them equals 180.
Add these two, subtract from 180. 65 plus 64 is 129.
Subtract 180
180 minus 129,
is
51. So this angle is 51 degrees. How could we find measure angle F? Add these two, subtract 180. 65 plus 64 is equal to 129. 180 minus 129, what is 180 minus 129? 51. Are these two angles congruent? Yeah. So that's how this works. The two of them are congruent. Well, the third angle only has one choice left to be, right? And they have to be the same choice. So two angles are congruent, the third one has to be. Regardless of what number we pick for this, for these two, it would have worked out. That's why I said, hey, just pick any number. Do you think I'd let you pick any number if it wouldn't work out any number?
So
No, I'd see you work one.
did you say that if two angles are congruent, then the third one has to be?
If two angles
Yeah.
are congruent to corresponding two angles, then the third angles are congruent.
But what about the other problem where they were all corresponding but one? 8, 5, and 8, 4.
That was sides. So this is angles. Good question. So Julie was saying, hey, what about this other problem back here where we had 8.5 and 8.4? Well, these were sides. So this doesn't work for sides. We can have two sides congruent and the third sides are not. But this does work for angles. It'll work for angles all the time. Okay? We're going to talk through this example real quick. So if you have two these triangles here, this is kind of messy and confusing, right? If you look at this picture, it might be a little bit of a mess. Well, here's something that can help us. Okay, here's something that can help us. Is if we separate the triangles. So we kind of have this triangle W, X, Y going on here. So let's just draw this triangle W, X, Y out here. Okay? And we know W has two arcs and it's 40 degrees. And we know Y has one arc, we don't know the measure. We don't know this angle. We don't know this angle though, because it's only this half of the angle, this part of the angle, and we don't know the whole thing.
35 times 35.
We don't know. I said half, we don't know if it's half. I misspoke. And then we'll draw the other one. We also have this other one right here. X, Y, Z. And so we can draw that triangle as well. Now notice, I repeated X and Y. Well, that's because X and Y is part of both triangles, right? Okay, so we know this angle has one arc and that's 35 degrees. This angle lies on this one. And this angle Z has two arcs. And we're trying to find the measure of YXW. Well, YXW, that's going to be this angle that we don't know right now. This angle up here that I'm circling. Okay, if you're not looking up here, you don't know which one I'm circling. This angle that I'm circling. Okay, that's what we're trying to find. Well, how can we go about this? Levi.
Well, you know Z is 40 because it's congruent to W.
Okay, Z and W are congruent. They both have two arcs, so it's also 40. Okay, that's something we know. 3.
Y on the purple triangle is 35.
Okay, how do you know this one's 35?
Because on the green triangle is
So on this top left, the purple one, y is going to be 35 degrees because it has one arc. X on this bottom right triangle, kind of this turquoise one, this teal one, has one arc so, and it's 35 degrees. So they're both 35 degrees. Okay? So how can this help us find W, X, Y? Zach,
Can you add W and Y and then subtract by 180?
why?
Because triangles add up to 180.
Very good, because all angles of a triangle have 180. So if we add W and Y, we get 40 plus 35, 75. 180 minus 75 is 105. So this angle is 105 degrees. So we answer the question by saying the measure of angle YXW is equal to 105 degrees. What other angle would be 105 degrees if this one's 105 degrees? Which other one?
The green one.
This teal angle Y? How do you know that one's on 105?
Wait, what?
How do you know this one's 105?
Because the other one was and added up to the same thing.
Okay? So Bree said, hey, this angle Y, or angle XYZ in this triangle together, would be 105 as well, because this angle X or angle YXW is 105. Because these angles are going to be congruent not only by our third angle theorem, but because the triangles will add up to 180 both, and they both have 40 and 35, so this one has to be 105. And that's also our third angle theorem coming into play. 40 and 35 were congruent, so 105 and 105 must be congruent. Questions on that one? So this one might have seemed really intimidating and hard to look at when we had them together, so separating the triangles can be a good idea. When you do it, you have to be careful which information you pull though. Okay, so we're going to look at this middle left example. Given triangle ABC is congruent to triangle DEF, find X. Oh, how could we go about this? Where are your minds turning? What are you thinking?
Put in 40 for E because it's congruent.
How do we know? Girls, how do we know B and E are congruent?
Because that's what it's given.
Okay, in our statement, B is the second letter, E is what letter?
No,
Second. So they're second and second, so they're corresponding and thus congruent because the triangles are congruent. So this one's 40, this one's 40. Okay, how does it help us?
It gives us an equation to do for DEF because if you do x plus x minus 58 plus 48, 40 equals 180.
Okay. So why does this equation work? Joe, I'm gonna have you explain this equation. Why does this equation work? Because all three angles add up to 180 in a triangle, and this is all three angles added together. Very good, thank you. So what would we start off by here? Jake, how would we start off solving this equation? Okay, well, let's look at it. Okay, just look at it. Is there anything on the left side of the equation that we can do? Combine like terms, less you less rings on F, less we forget. So what are some like terms we can combine here? Sorry, say it louder. The x's. X and x combine to be 2x. Very good. Okay?
And then you
Emma, what are some other like terms we can combine?
Is 58 or 40?
58 and 40. What kind of 58 is this, Emma? Very good. It's a negative 58. So what's negative 58 and 40 combined to be? Negative 18. So 2x minus 18 is equal to 180, okay? So now what would we do here, Joe?
You add 18,
Very good.
and then that cancels out, then you add it to 180. You get 198, then 2 divided.
Very good, okay? So we add 18 to both sides, gets rid of the 18 over here, gets 2x equal to 98, divided by 2. X is equal to
Oh, 198.
99.
Wow, that's crazy.
Questions on that one? Very good, okay? So the different part of that, the new part of that was our setup, was how we got here. Knowing that this was 40, this was 40. That was our new part. Everything else we've done. We've done equations, we've added angles of a triangle to be 180. We've solved equations to find x This was our new part, the first part. Did that one? Okay. Go to this bottom one. There are 4.4 properties of congruent triangles. We have the reflexive property of congruent triangles. For any triangle, ABC, triangle ABC is congruent to, well, what's the reflexive property? What's that meant? What did that tell us before? We learned reflexive property back in chapter 2, section 4. Julia?
It means it's flipped, or it's the exact same.
It's the exact same.
Yeah.
So triangle ABC is congruent to triangle
ABC.
ABC. Reflexive, anything's congruent to itself. Okay, ABC, easy as 1, 2, 3. The symmetric property is what property? Where we take it and we do something to it. Joe? You flip it, you put it the other way. So triangle ABC is congruent to triangle DEF. Then what, Joe?
Triangle CBA.
I don't know if that.
Oh, I get what you're saying. Okay, so we'll flip the order. We'll flip the sides.
Yeah. So DEF
Yep.
is congruent to ABC.
Very good. Okay, so we don't want to rearrange the triangles. Instead, we don't want to rearrange the letters in the triangle. We want to switch positions for the triangles. Kind of like if it was a converse. So triangle ABC is congruent to triangle DF then. Well, triangle DF is congruent to triangle ABCS using our symmetric property where we flip them. Okay, transitive property. Who can tell me what this would give us if triangle ABC is congruent to triangle DF? Triangle DF is congruent to JKL. Then, Eric.
Triangle ABC will be congruent to triangle JKL.
Very good. Triangle ABC is congruent to triangle JKL. The transitive property is where we say, hey, look, these triangles are both congruent to triangle DEF. So we'll cut out the middleman and go straight from the first to the third one. And we also have 3 of these congruent symbols in a row. And we talked about the transitive property a whole lot here, right? Okay. Do we have enough information to prove this triangle, these 2 triangles congruent? Okay, we have this triangle FHE, and we have this triangle down here, GH, well, I thought I changed colors, GHF. Do we have enough information to prove these triangles congruent? You guys are saying yes, but I only see 2 sides and the 3 angles.
What
So
about
we-
this little angle right there?
Okay, it makes a rectangle, it does make a rectangle. Okay, convince me. Okay. Page.
Well, there's 2 right angles, which they're both congruent.
Okay. So these angles are congruent. These angles with the 2 tick marks are congruent, and these angles with the 1 tick mark are congruent. So we have all the angles.
It means yes. because
We have 2 of the sides. We have FE and GH, and we have FG and HE, but we don't have the 3rd sides. You want to say something?
Never mind.
Okay, good talk.
Me too.
Okay, FH. That's the side we're missing for both of these, right?
Wait, let me see. FH.
Yes, sir.
Yeah,
If everything else is congruent, those have to be congruent.
not necessarily.
We'll learn that. Dominic?
They both have FH
Okay.
equal to each other.
Because if is FH congruent to FH? How do we know segment FH is congruent to segment FH? The reflexive property of congruence. Very good. No. Reflexive. Okay, so we'll put 3 tick marks here and say, hey, this is congruent to itself. Something's congruent to itself.
1, 2.
So, in fact, triangle FEH is congruent to triangle
We
HG.
use the
F.
transitive property, didn't we?
No, we use the reflexive property. Yeah, because we're saying that FH was congruent to itself.
Is it work time? We use the last 2 minutes of work time? Last 7 minutes?
1 second.
What was it to say?
It's
the square. It's not a square.
It's not a square, no.
Like,
Gotcha.
I was like, it's not 360. That's a circle.
Correct.
Makes sense.
But it actually does cut to 360 degrees.
It does.
Yeah, but that's something we'll learn next semester. But that wouldn't help us right now. Okay, we are going to skip the next example. On the next page, we have this example. Yeah, we're going to skip that. I think it's actually. How does it make you feel? Hey, some information that might be pertinent to you. What's pertinent mean, guys?
Useful.
Important or useful. Valuable to you. Rude. We only have about 5 minutes left, but sure. That says 5, 7, 9, 11. Is that better, Zach?